Hello, my name is Thais Damasio, and I'm a master's degree student at UFMG. This is one of many videos in a series about programming language. Today, we are going to talk about Kotlin and its extension functions. Before we start talking about extension functions, let's first understand Kotlin in a nutshell. Kotlin is a JVM language, which means that we can run Kotlin programs using the Java virtual machine. Kotlin is widely used with the Android platform, which supports this programming language. This may raise questions about the difference between Kotlin and Java. One of the best advantages of using Kotlin is that it is more concise and safer alternative to Java. We can justify these properties with the following difference between these two languages. By default, variables in Kotlin are not null, unlike in Java. This prevents issues with invalid pointers, for instance. An object-oriented programming language like Java tends to change the state of variables during the execution of a program, and sometimes this can be a kind of tricky. Kotlin allows us to use functional programming to avoid this mutable behavior. Java also has its advantages, but discussing them is not the goal of this presentation. So now, let's see an example of application before I talk about extension functions. Suppose that we want to represent an employee entity. We can create a class with the following attributes: name, occupation, salary, and currency, which describes the system of money used by the employee. We want to use the printinfo function to output the data about an employee, as shown in this screen on the right. We can represent this abstraction using a class in Kotlin that will have the attributes of an employee, and a function to generate our desired output. First, we can print the title of our output and the name of our employee, the occupation, and finally the salary. Notice that we need to check which currency the employee uses in order to select the appropriate currency symbol. Here we have only two options: BRL for Brazilian real or USD for US dollars. How can you add another currency type? We can add another statement in the when block, or many other statements depend on the number of currencies that we want to handle. Does printinfo have more responsibilities than necessary? Perhaps this behavior should be handled by the salary property. The printinfo method of the type of the employee class should only be responsible for displaying the information about an employee and not for handling the currency value. Let's think about a way to solve this problem. Perhaps we can create a new entity called salary. This entity will have a method called value with currency that will be responsible for returning the salary with the correct symbol based on the currency value. And here we have our salary class in Kotlin with the attributes that we saw previously, and the value with currency method. We will put here the when condition that defines which symbol we are going to use. So we will return a string with the currency symbol and the salary value. Our salary class is done. We can rewrite our employee class using the salary class as a type of the salary attribute. The printinfo method keeps printing the general information about the employee. But now, the salary itself will be responsible for returning the correct format that will be printed. Okay, but let's consider the solution. We have created another abstraction, a class in this case. Does this class serve any other purpose in our code? Or are you using a sledgehammer to crack a nut? What about extension functions? Extension functions is a way to add new functions to an existing class or primitive data type. We can do this without inheritance. But the extension only exists in the scope where it was created. We will discuss this further later on. Let's return to our employee class. How can we print the salary with the correct currency symbol using an extension function? A salary is represented by a double type, which is a primitive data type in Kotlin, so we can define extension functions for it. The extension syntax consists of a function declaration that starts with the name of the type being extended followed by a dot, and the function name with the parameters, if they exist, the type of return, and finally the function body. We will use the when block here. Now we need to emphasize two important things. First, this keyword inside of an extension function refers to the type being extended. In this case, this is referring to the double type. Second, as we have declared the extension function inside the employee class, we can also access the attributes of this class. This is possible because the extension function only exists when you create an instance of employee. If you want to access a property of an employee from within the extension function, we need to use this keyword followed by an add symbol and the name of the class. Now we can get the currency value of the employee instance, and inside the printf function, we can call the extension method from the salary attribute, as it is of type double. Our employee class is ready to use, so let's use it. To demonstrate how the code works, let's create an instance of the employee class in our main function. Let's initialize this instance with the following values. The name will be Danilo, the occupation will be software engineer, the salary will be 5,590, and the currency will be USD. If you call the printinfo method, we will get this output. Notice the currency symbol. But if we print the salary attribute directly, we will get this output, the pure double without the currency symbol. But what happens if you try to access the extending method? An error. This is because of the limited scope of an extension function. This extension function was declared inside the employee class, so its scope is limited to employee instance only. Therefore, it cannot be accessed directly outside of its declared scope. But we can create this extension in the same module of our main function. When moving an extension function from the employee class to the same module as the main function, we need to modify the function to receive the currency attribute as a parameter, since it can no longer access the properties of the employee class directly. And we use the currency parameter as the condition of our when block. Now, we can call this extension method passing the currency as a parameter. Nice! Here is our output. But should all double type in this module extend this method? Suppose that our main function creates a double variable called weight. Since weight is a double data type, we can do something pretty weird. We can print the weight with a currency symbol. Here is our output. In order to define the scope of an extension function, we need to analyze the context of a problem. Cool. We can add functions to an existing class using extension functions. However, we can also accomplish this using inheritance. What is the difference after all? We kind of extended double, which is a final class. It is a primitive data type. We cannot do it using inheritance. But inheritance allows us to access protected members, unlike extension functions. Inheritance also allows us to add new properties and methods to the derived class, whereas extension functions cannot add new fields to the type. However, We do not need to create subclasses with extension functions, make them less verbose and more concise. Which should we use? The choice between inheritance and extension functions depends on the context, scope, or design of the application. Each solution provides benefits that can be used more effectively in different situations, as we have seen. How do extension functions work? So, the code that we have seen, which defines an extension function, will be statically solved. In the end, extension functions will be transformed into normal static methods. Thus, there will be no direct relationship between the extending class and the extension method. Let's take a look at an example. Here is the extension function that we created earlier. This extension function will be transformed into this static function on the right. We keep the same signature as the original extension function, but without the dot. We also keep the parameters of the original function. The class for which we created the extension function will be transformed into a parameter of the static method. This parameter will have the same type as the class. And note that all these keywords will be replaced by the use of the instance parameter. That's all about extension functions. Thank you so much for your attention and feel free to ask any questions. Bye bye.